Okay, so we're going to be doing question 6, paper 1, variant 2 of 2010 November. And this is question 6, so please refer to the question while this lecture goes on. And question 6 says, a curve has an equation y is equal to kx squared plus 1. And a line has an equation y is equal to kx, where k is a non-zero constant. So k cannot equal to 0. This is a 0. Now, the part 1 says, find the set of values for k for which curve and the line have no common points. So if they don't have any common points, first let's get an equation for this. We see a y over here and we see a y over here. So we can immediately equate these 2 points, these 2 equations. So let's equate them. We get kx squared plus 1 is equal to kx. If we simplify this, we get kx squared minus kx plus 1 is equal to 0. Now this is our equation. It's in the form of a quadratic equation. That is x squared plus x plus 1 equal to 0. 1 is the constant. Now, we can use a special quadratic formula, let me make this full screen, called b squared minus 4ac minus 4ac plus minus 4ac. And this is a very key formula. The reason is we can find out how 2 equations like this, if they ask you in the problems, how many points do 2 equations like one quadratic equation and one linear equation intercept, and they say make it intercept 0 times, 1 time, or 2 times, then this equation comes in handy. This equation can also apply in some other place where we will be talking about it sooner or later. So let's use this equation. We know that b in this case is equal to k minus k. We know that a is equal to k, and we know that c is equal to 1. We've done this in a previous lecture, so if you have any problems, please refer there. But if you want me to review it, I will say that this is a, this coefficient is b. I'm taking only coefficients here. And this coefficient is c. Now, b squared minus 4ac is k squared minus 4 into k. And we want it to intercept at, let's see the problem now. It should have no common points. That means the 2 should not intercept at all. So, we don't want it to intercept. If there's no interception, that means no point in common between these 2 equations. If there's no point in common, no points in common, then that means we need to equate this formula, k squared minus 4k, we need to make it less than 0. It needs to be a negative value. So, what are the values of k for which this is less than 0? Let's take k, the subject of the formula here. We get k minus 4 less than 0. So, if we draw a number line here, I'll clear this page. I hope you've got it. If we draw a number line here. Now, how I approach quadratic inequalities is I always draw a number line. It's a key way to do it. Actually, it's a good way to do it. Many people do it some other ways, but this is a good way to do it. Now, if we put 0 in the center, what will be the values of k for which k squared minus 4k will equal to 0? Let's take that first. It's always good to approach it this way. We know that this will equal to the second part, that is this part, and k will equal to 0 or k will equal to 4. Now let's plot those 2 points. So 1, 2, 3, 4. Plot this and plot this. Now, as you can see, we have 3 ranges in this number line. One range is k being less than 0. Another range is k being greater than 0 but less than 4. Finally, another range is k being greater than 4. Now these three ranges we have to test out. So let me mark these three ranges on the number line. This is range 1. Hope you can see that there. This is range 2. And I think you know what range 3 is. It's this part. Now, what we have to do is we have to take 1 point from each of these ranges and test it out in our equation over here. So on our range k less than 0, let's take k equal to minus 1 because minus 1 is less than 0 and test it out in this. What do we get? We get minus 1 squared plus 4. Minus 1 squared plus 4 is less than 0? No. So therefore this range does not work. So we cross it off immediately. Now we take a range from 0 less than k less than 4. Let's take k equal to 2. If we take 2, let's take k equal to 2. If we take 2, we get 4 minus. I'm just inputting the value of k that I choose over here. Now if we take 2, we get 2 squared 4. 4 minus 8 is minus 4. Does that work? Is k less than 0? Yes. So we'll keep this. I'll put a check mark on it. Now we take k greater than 4. So greater than 4 means 5. So 25 minus 20. And is that less than 0? No. So we cross this out. Therefore, our final answer has to be k greater than 0, less than 4. This is one of our answers. I hope you understood that. Now let's go on to the second part. Let me see which page I can clear here. I think I can clear this one. I hope you've got this. Okay. Now the second part states that state the value of k for which the line y is equal to kx is tangent to the curve. Curve means y is equal to kx squared plus 1. You can immediately recognize that this is a curve. I'll change my ink here. You can immediately recognize that this is a curve. It's a quadratic curve because of the highest power being 2. So, state the value of k for which the line is tangent to the curve, and for this case, find the coordinates of the point for which the line touches the curve. So, when a line is tangent to a curve, that means it meets at only one point. It meets at only one point. Remember this rule. This is a key rule. It's applied everywhere in AS level. So let's first find out what this value of k is for which it's a tangent. How do we do that? We did in the previous problem that this equation number 1 and equation number 2 meet at 0 points. Now, since they say that the line y is equal to kx meets y is equal to kx squared plus 1 at 1 point, our b squared minus 4ac will equal to 0. We can use that magic formula again, that magic b squared minus 4ac again. So I'm just going to clear this page. I hope you got this down. So first, let's make one equation out of this. As there's a y over here, there's a y over here, so I equate them. Kx is equal to kx squared plus 1. Now, we can say that kx squared plus 1 minus kx is equal to 0. Now, our a over here is equal to k, our b is equal to minus k, our c is equal to 1. Now, we want our b squared minus 4ac equal to 0 because it intercepts only at one point because it's a tangent. So we want k squared minus 4 into k equal to 0. Now what's our value of k over here? We do the same method. We get k equal to 0 and k equal to 4. But we can already eliminate k equal to 0 because in the problem they said k is non-zero. So eliminate this. So we have our final answer as k equal to 4. Now it says state what value the line y is equal to kx intercepts at that one point y is equal to kx squared plus 1. How do we find that? So let's substitute for k in both equations. In equation number 2, we have y is equal to 4x squared plus 1. And in equation number 1, we have y is equal to 4x. Now, I think I can clear this page. I hope you've got this done. Now, we know that the slope of the line in y is equal to 4x, the slope of the line, we denote it as m, is equal to 4. Because the coefficient of x in the form y is equal to mx plus c. In this case, c is equal to 0, so it's y is equal to mx. M is always the slope. So, we know that m for the line is equal to 4. So, that means we want to know at which point of this graph is the slope equal to 4. Because at that point is where the tangent is going to be. So how do we find that? Well, obviously we have to differentiate the equation to get at what point, because it's a curve, we have to get at what point the slope is equal to 4. So differentiate the curve. Differentiate dy by dx of this equation. And we get 8x plus 0. I hope you see how I got that there. Now we want dy by dx equal to 4, because we want to know at which point of the curve our slope is equal to 4. That is, our slope is equal to the slope of this line. That's where the tangent will be. So we have 8x is equal to 4, x is equal to 1 by 2. So let's keep our x value. I will just erase this page. Now we want to know our y value. So we had two equations. We had y is equal to 4x and we had y is equal to 4x squared plus 1. We can put the value of x that we got over here into any of these two equations and get our y value. So let's put it in the easier equation. Obviously, it's the line one. It's the easier one. So we have y is equal to 4 into 1 by 2. So y is equal to 2. So our final coordinates are 1 by 2, 2. And this is our final answer. You can check the marking scheme. It says the same thing. I hope this helped you. If you have any questions, please email me.